Now, why is the transfer function theorem so important? Again, the reason is very similar to what we had when we discussed a time invariant network. So, let us say this is LPTV at Fs, this is n, right, and let us say you had multiple sources. So, let us call this e to the j, let us call this V S1, let us call this IS2, blah blah blah, right. You have multiple sources and you have one output, and so let us say this is V out 1, right, and so let us say so VSN, let us say. So, and all these let us say all sources have frequencies some f, okay, all right. So, the output is to find the output at f, what would we do? What would we have to do normally if we did not know about reciprocity?
You have to apply the operation. At every source we have to apply that.
So, basically what we would do would be apply superposition, right. At you analyze the network one source at a time and you find the transfer function from Vs1 to the output, find the transfer function from Is2 to the output, we find the transfer function from Vsn, the nth source, to the output, right, and that is a very laborious process. And we basically let us say need the component of V out 1 at f, all right, and this is a very laborious process. All right. So, what one can do is use reciprocity what do we do with reciprocity? We, if we call this transfer function H01 of J2 pi f, this is H02 of J2 pi f, this is H0n of J2 pi f, right, which are the zeroth order harmonic transfer functions corresponding to the first, second, third, all the way up to the nth source. Now, what are we going to do? Instead of doing this by superposition and doing the analysis n times, what we will do is exploit reciprocity. What do we apply?
We apply the current source at the output.
We apply a current source at the output at f, so e to the j 2 pi f t, all right, and this current is going to be H01 of j 2 pi f, this voltage is going to be H02 of j 2 pi f, and this is going to be H0n of J2 by f, right. So, this is the reciprocal or inter-reciprocal, I must say, or equivalently the adjoint network. You excite the output port of the adjoint, right, after following all the elementary placement rules, right, and in one shot you are able to get all the transfer functions. All right. So, this is a all transfer functions obtained in one shot. All right. Does that make sense? Very good. So, now so in other words, we are remember the reason we are looking at the output frequency, we are looking at the output frequency, the output voltage with a frequency component of f, right. But this is an LPTV network. So, it is not merely it is, of course, it is not single frequency at the output, and it is also not that the output at f is only because of the inputs at f. If these sources Vs1, Vs2, Vsn had components at f plus some L times Fs, they will also translate to the output at frequency f, right.